vector and scalar quantities. First of all, vector from last year, you know already. Scalar quantity is a physical quantity that has magnitude only, no direction. Examples: speed, time, distance. And then we have more. We can add temperature, and then what else? Mass also we can add here. And vector quantity, magnitude and direction, number, unit, and direction. You know already from last year. And then vector addition. Today we are going to be busy questions about vector addition and calculating net force. It is easy one if they have same direction. You must just add them. If you have opposite direction, formula is still same, a plus b, but one is positive, other one is negative. You are choosing direction. For example, to the right, positive, to the left, negative, and then you are calculating, you are adding them all. And resultant vector, it means net vector, net force. When you are calculating force, this year, people, we are busy with force. Mostly you will see people force, types of force, calculating net force, using force to get acceleration. We are busy with force in term 1. And you have other options to show, as you see, tail to head method from last year, you know that. What else we have, people? Just drawing and showing resultant force with other method, as you see, drawing lines parallel to A, parallel to B, and from tails to that connection point you are drawing. This formula, today we are answering some question about this formula, people. This means parallel one. Sometimes you can say fx also, horizontal one, because we have x and y axis. Let's just try to show. This is new for you. Last year we didn't learn, so this is new for you. Just and then we are going to answer too many questions about that. First of all, let's show what does mean parallel and perpendicular. If you have like this x and y axis, we are using, people. This is x axis and y axis. So if you have a force here, let's just show. Force start from here, first one from 0 point, and then this is your force, and with angle. With this angle, if you want to get component on x-axis, parallel one, or you can say ax or fx. Okay, horizontal one. We are getting this one. First of all, drawing dots, and then this is here. This is our f parallel. How we are calculating f parallel, people? Force times f parallel equals force times cos angle. So this is our parallel force. And then when you come to next one for y-axis, fy equals f times sine. So you will see examples today. So this one, horizontal and perpendicular we have. After that, people, if you know fx, fy, and then you need to calculate f, just opposite, just like this one. If you know f1, and then another one f2, and then if they ask you calculate resultant force, but they are perpendicular, right? So they're asking to calculate resultant force, you are using this formula. F net equals, normally you know f net square equals f1 square plus f2 square, and then you can write square root each f1 plus f2 and that. So we are going to use this formula if you have any forces perpendicular. First of all, people, you are getting components. For example, you have this and other forces all together. Finally, you will have something like this. And then you can use this formula. To get angle, this formula we have, but we are not using this one for now. We can leave it for now, not urgent. All right, let's continue, people. What else we are going to learn quickly, let's say, and then we can go to that page 65. Mechanics, our topic. Types of forces, starting with types of forces. First of all, people, we have some definitions, all right, in our textbook. We are gonna make list what we have, all definitions, everything we are making list, and then you will get it on Google Classroom, or I can make copy for you. But please make sure you know all definitions. Today, just I will mention which one you should know. Number one, force. We should know. We will not focus on all definitions. Just I will tell you what we have to know. Force is number one. Push or pull on an object. And then when you go to types of forces, we have two different groups, forces, people. Field forces, contact forces. Field forces, gravitational force. You know already from last year. Gravitational force, other name is weight. Weight equals gravitational force. Gravitational force on a planet X, on an object, is called weight. So this is another definition you should know. Gravitational force or weight. And magnetic, we are using this one, people, in this topic. But when you come to magnetic force, electrostatic force, not in this topic, mostly term 2 and term 3. We are going to study, we are going to learn. But field force, we have gravitational force, magnetic force, and electrostatic force. When you come to contact forces, first one, applied force. If it is in question, you can use it, otherwise leave it. So applied force, which one? Just apply on an object. Next one, normal force. People, in your question, mostly you will not see normal force, but you know if you have surface here, if any connection, you are going to use normal force. So let's draw. You will have question like this. You will have a box, and then there's a force here, applied force. And then they will ask you people free body diagram. Yes, one learner asking about free body diagram. So now, how many forces we have? If we have friction force also here, mostly they don't show also friction force. We should know if you have, if they said no friction, it's fine. Otherwise, you have to show. One force is always, it is here. What's that? Gravitational force, Fg. And then if connection between another surface, this is, start from here, people, normal force. It is Fn. And we have friction force. And we have friction force, F we are showing. Okay, how we are drawing free body diagram? It is easy, people. Just forget about this box. To take a point. Okay, this is our point. And then, how many forces you have, everything coming to this point. Now, let's check. We have applied force here, number one, to the right. We are drawing. It is F. And when you come to next one, friction force, opposite to motion. More details, everything we are going to learn, people. For now, just explain it because we are going to answer questions on page 68. Okay, opposite each other. And then what else we have? We have normal force, up. And then gravitational force, down. That's it. This is our free body diagram for this object. Depends on forces. What forces you have, you are just showing on a point. If you have more forces, for example, applied force 1, let's say, we have another one force here, F2. How we are going to show it? We are just showing on this, F2, F1. After that, calculations. Okay, calculations coming, examples coming now. I hope it is clear. How can we draw free body diagram? All right, let's continue with types of forces. Normal force, we said, opposite to gravitational force. And then tension force, we have friction force. All types of forces, people. And Newton's law, we are going to learn. Of course, we cannot finish everything today, just showing what we are going to learn, people, right? What we have. So tension force, Newton's first law, if F net is 0, acceleration is 0. Basically like that, all right, guys? So all definitions, everything coming. Newton's first law, force is 0. Net force is 0. So now let's continue. with next one. Newton's second law is coming now. Inertia and mass coming, we're going to explain later on. Newton's second law, F net is not zero now. You have applied force, you have net force. If you have a net force, of course, you're going to have acceleration. Object will move, object will change direction, and then we can say we have acceleration. Speed up or slowing down, but velocity will change. Next, we are going to have acceleration. Newton's second law and all examples coming following weeks. We are going to answer these questions also. Newton's third law, when you come to Newton's third law, people, you are going to see action and reaction force. When you have action force, same, you are going to have reaction force, opposite to that action force. Examples here, people, action and reaction force. There's no formula, nothing for this. Only know if you have action force, you have opposite direction reaction force. And then people, we are going to carry on with universal gravitation. Universal gravitation, just like we remember last year, we have Q1, Q2 charges, and then there's electric force between Q1 and Q2. Now, similar one, but no charge, only objects. All objects, between any two objects, people, there is gravitational force. How can we calculate it? Formula is here. During exam, you will have it. Force equals G times, it is new for you. G is constant number, people, gravitational constant. 6,67 times 10 to the power of negative 11. So don't worry about it. You will have it during exam. M1 is mass for first object. M2 is mass for second object. And then R is distance between two objects. We are going to use this formula to calculate gravitational force. And then what else we have? Let's continue. Gravitational acceleration, you know already that. Gravitational acceleration is 9.8 meters per second for Earth. Gravitational acceleration. Mass is a quantity of matter. You can highlight on your notebooks, or you can wait for our list, or you can make your list, people, for all definitions, but please don't try to miss any mark because of definitions. Weight is, for weight, you can say gravitational force. The weight on an object on Earth is gravitational force of Earth. So if they ask what is weight, you can say this one, weight is gravitational force. Units, symbols, everything done. This one, connection between gravitational force, Google Classroom. Yes, we have Google Classroom, just like last year, same code, everything same. I'm gonna just carry on. I changed name from grade 10 to 11. We have Google Classroom. Please join there, and then you can see our videos, everything. Just I'm trying to make videos for you. And then even this lesson I will share with you. All right. We have Google Classroom. Please make sure you are joining. Okay, let's continue. This connection is coming later on. We are going to explain. Today, just I want to show what we are going to learn. All right, please don't ask me about details or all. But for now, just let's see what we are going to learn. We have examples about gravitational force, friction force. So people, friction force, opposite direction of motion. If you want to push any object, or if you want to pull any object, you are going to feel that force, opposite of motion. We have two types of force. We will see static friction, two types friction force, static friction and kinetic friction. Static friction, before start moving, you see definition here. Static friction is the friction between two surfaces that are not moving past each other. Object at rest, you are trying to push, but object is not moving. That time you have static friction. But when you start moving with object, that time you are having kinetic friction. We have formula here. Formulas, everything is coming later on. More details coming next lessons. So kinetic friction. Kinetic friction, when objects start moving, now you are stronger than friction force. You start moving, that time you have kinetic friction. All right, let's continue. So these details, cases, everything coming, showing all cases. Okay. From now, yeah, now we can go to page 64 and answer our questions. 64. Rest of them free body diagrams and lift problems, everything. When we start answering our questions, we can explain. Don't worry about that. From now, if you have any difficulties, any problem, you can ask. All right. So far, I was just trying to show what we are going to learn. Okay, question 1. Today we have 5 questions about vectors, calculating net force, calculating total vector, just we are calculating people. Question 1. K and L, magnitude 7 units and 5 units. And then asking you people, calculate the magnitude and direction of resultant vector, K plus L. Okay. We have different options to answer this question. We'll try to show maybe 2 options. First of all, let's use getting components of vector, K and L components we are having people, and then we are gonna add them. That's it. And second option, using just taking L from here and put it here and drawing. Second option, we are gonna draw and then show direction. To show direction, we are drawing. Okay, first of all, from last year, we know already you can take this L without changing direction and then put end of, just head of L or head of K. Okay, how many units we have? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Start from here, and then this is our L. That's my drawing, sorry. It is L, and now we know from last year also tail to head method. Tail to head method, we have people. Let's draw from tail of K to L. This is R. That's it. This is now showing you direction. But what they said, direction and magnitude. So how we are going to calculate magnitude, people? For this one also, we have options. Let's start with option 1. And then you can use which one easy for you. Option 1. L is 5 units. And K is how many? 7. 7 units. And then you are using R square equals 5 square plus 7 square, and then R equals square root 25 plus 49. And then when you calculate it, what are we getting? 8.6 newtons. 8.6 newtons. Direction is here, and then we have done. I hope it is clear, people. Question 1. Do you have any difficulties? Please ask on chat. First of all, we are showing on the diagram, we are taking L without changing direction and put head of K. After that, we are drawing a line from tail of K to head of L. It is our option 1, and then we are calculating option 2. Option 2, using X and Y, using our X and Y. First of all, people, F, let's say use, we don't need F force, we don't need for now. Let's say Kx on our, okay, let's say Kx. We are going to use Kx and Ky, same thing. Finally, we have same thing. What is Kx? If you just draw, okay, this color is not. If you have x-axis and y-axis, if you draw like this, this is your x and this is your y. And then K, as you see on x-axis, Kx is northeast. Okay, one word asking about direction, we can say northeast, not just north, northeast. Okay, so First of all, people, maybe we can draw it here. If you want to draw on y and x axis, this is your first vector. K is here. K is here, and then L is that side. L is there, and then answer is this one 7 and this one has 5. So Kx, what is Kx on chat? Can you please let me know? What is Kx? What is Ky? On horizontal maths paper 2, I think you know that. Kx, Ky. And then we need Lx, Ly. Just check. Okay, on chat, our answer is coming now. Kx, 7 units. Perfect. Thank you very much. Kx, 7 units. And Ky, 0. That's good. Answer is coming. Thank you very much. Ky is 0. Kx, 7. And then Lx. What is Lx? Please check for Lx and Ly. Lx is, yes, your answer is correct. We have one correct answer, but I will wait for other learners. Everyone, please try. If you get Lxy, finally you will have this formula. Lx is, yes, you only one correct answer. Please just send me answers direct message, not to everyone. Okay, now everyone see. Please send direct message, much better. Lx is 0, Ly is 5. That's good. Thank you very much. Now, people, we can calculate for x and for y. Let's say Rx equals Kx plus K, so Lx, just calculating for x and for y, and then you are going to use this formula. You can say it was easy, why we are in long way, but other questions we are going to use this one, people. Our Kx plus Lx. So Kx is 7, Lx is 0, and then Rx is 7 units. Next one, Ry. Ry equals Ky plus Ly, and we have 0 plus 5, getting 5 units. I hope everything is clear. What are we trying to do, people? On our system, x and y, we are trying to show all forces on this system. After that, easy to calculate, people, because other questions you will see too many forces same time. But if you put everything on this system, from after that, all same thing. Just say this formula we are going to use, people. So now, how can we calculate R? R equals, let's write here, R equals square root Rx square plus Ry square. So from now, exactly the same. This here is coming. Rx is what we have, 7 units plus 5, and then you are getting 8,6 meters. All right, guys, we are using x and y axis. This system we are using to get our resultant force. So direction, if you, without showing on the diagram direction, just check this one, people. You can also draw, yeah, you can just show here, you can draw dots and then you will see. Okay, on this system also, how can we show direction? Just drawing parallel. I think you remember this option, showing resistance. So you can show, this is R, done. All right, option 1, on the diagram, we did draw and then showing like this from tail to head. And then option 2 for direction. First of all, we are getting Kx, Ky, Lx, Ly, and then you are adding Kx. If you have opposite direction, please remember, if you have any force this side, it is negative. Please don't forget it for x. If for y, if something is going down, it's going to be negative. Yes, we have 2 options. Yes, we have more options, but not now. All right, with angles, so we can calculate sine, cosine, so we can use other options. But for now, it's enough. We have 2 options. All right, let's continue, people, with next question. If you have another question, please ask me about question 1. If you cannot finish 5 questions, it's fine. We can carry on next lesson. But let's make sure you are getting it, people. Do you know? If you understand from now, our method, our options, Rx. Okay, where is Rx? Rx is here. Just K plus Kx plus Lx. Rx is this one. You can just see Kx is here, Lx is 0. You know that. So Rx together, these two is Rx. Okay, let's draw one more time. Oh, you get, okay, understand. All right. So on, and then this is Ry. When you add Rx, Ry, and then you are calculating. Let's see another question here. Oh, I will post it. Yes, of course, I will post it. And the next lesson also I will post. And then I will post some videos for you guys. And then I'm going to post all definition lists from now. All right. And then you can study. Yes, red and blue different options. Yes, we are trying to show different options. And then people, I'm trying to give just extra lesson also during the week. So just let's make sure if you need help, I will tell you which day for you. All right, you can come, you can join. It's another option. Just let's make sure everyone getting good mark. All right. Physics this year it's easy, but we need more practice. Okay. That question, there is no more question. We can carry on with question 2. I will share this one also, or you can just take it from now also, it's fine. Another question. Yeah, trial test we'll try. Yes, I will share on Google Classroom some trial tests for you. I will share question first after 1 week, and then I will share memorandum, and then I'm going to answer for you also on Google Classroom. Yes, we are going to make trial test. Thank you. So we can carry on with question 2. Today I said 5, but anyway, it's fine because we start and show what we are going to learn everything. We can carry on with next question. Question 2. Okay. For this question, second option is much better because drawing is difficult, just taking and doing a drawing. So let's use second option for this question to remember X, Y, those things. Okay, first of all, people, what they said, now R is given, resultant force is given, A is given, asking you B. So if you don't know that X, Y, X is, so you are going to get lost. But if you see that, it's easy, people. Okay, you will see now. Let's start and draw our x-axis, y-axis. Okay, let's change color because okay. This is our x-axis, people. Sorry. This is x. Okay, red is best. So this is x, and then we have y here. Just we can show it is our y-axis. And I'm sure you are going to help me now to get AX, AY, and then RX, RY. Okay, please help me for that. RX, what is RX? Please let me know. And then RY we need. And we need AX and AY. Or other option, people, to show, you can say R parallel and then R perpendicular. All right, it is the same thing. You can use this showing or this one. In physics textbook, mostly like this. You will see parallel means X. I'm saying XY because I want to explain with our system. Okay, I hope answer is coming now. And then A parallel and A perpendicular. All right, so answers, Rx is 0, Ry, AY is 0. Okay, let's see. Another answer from you people. Rx, number 1, Rx is 0. Because, as you see, people, on y-axis. And then Ry is, yes, Ry is coming. Google Classroom codes. Yes, I will try to share before just end the lesson. All right, I will share Google Classroom code. R perpendicular, Ry is 6. That's good. And then AX, what is AX? What is AX? Please check. And then AY. AX, let's say 1, 2, 3, 4, 5. Okay, it is 5. And then AY, just come this side, 1, 2, but negative 2. All right, please use it. Or you can say direction here, negative showing direction. Yes, perfect, that's good. From now, people, what we know, to get R, as you see, R equals A plus B, right? So for Rx, how can we get Rx equals, we know AX plus BX, right? And then we know Rx is 0 equals AX is, what's that, 5 plus BX. Now we can get BX. What is BX, people? BX equals negative 5. I think you are getting it, huh? So you are BX done. And then what we need, BY also. How can we get BY? Let's calculate BY now. BY equals, well, let's carry on with RY. RY equals AY plus BY. And then RY, what was the RY? It is 6. R perpendicular is 6. And then AY, A perpendicular is negative 2 plus BY. Negative 2 is going that side. And then BY equals 8 units. All units, people. All right, just let's say units. From now, I think it's easy, right? We can just calculate B equals square root BX square and then BY. Are you getting it, people? Any question? Let's see. Why? How is AY is negative? AY, as you see, it's going down. Check, just like this. It start from 0. If it's going up, if it's this side, if it's going up, positive, otherwise negative. This side, negative Y. All right. And then let's finish it. I hope it is clear. Okay. First of all, you are getting for X and Y. You are getting X and Y for all, for R, for A. After that, RY, RX, we are just calculating. We are trying to get B for B, X, and Y. I hope it is clear now. Because of time, just let me finish, and then next lesson we are carry on with this question also one more time we can explain. Square root, what we have, BX is 5, negative 5 square plus 8 square, and then you are getting B is, we are calculating finally 25 plus 64, and then when you calculate, you are getting it units. Just say units. Can you please calculate for me? Just getting units. And then direction. How we are gonna get direction of B? Just use X and Y axis one more time, and then you are gonna get it. Answers 9.43. Thank you very much. 9.43. It is first lesson. It is the first time we are answering this kind of questions. Don't worry about that, people. If you don't get it, next lesson you will get, I'm sure. And then you can ask me on WhatsApp also if you have any question. But please try one more time. Okay, just using our method and try. Why AX is negative 2? AY, yeah, AY is negative because it is going down, people. This is AY. When you come from head of A, just come this side, and then you see this is AY. As you see, it is going down. Because of that, it is negative. All right. Direction, okay, direction is coming down. Direction is northwest. Yes, you are right. Why? Because we are going to just show on our XY system, BX, BY. So where is BX? BX, what we said? Negative 5. So it means this way. BX is here. Okay, where is BY? It is positive. So BY this way. This is BY. Now it is easy to show our B this direction. I hope it is clear, people. Even you can show also here, just B is here. What we know, people, from tail to head using to get resultant force from tail of A